Welcome back. In this video, we are going to review similar triangles and proportionality theorems. In our first pair of triangles, we want to solve for x, and x is between 2 and 3 arcs, so that corresponds with this 29.5. So I'm just going to draw an arrow. There's my first fraction. X is to 29.5 as, and then I can do 19.5 is to 39, or I can just avoid fractions and do 21 is to 42. So now I will cross multiply, and that's 42x equals 21 times 29.5 is 619.5. And I can divide both sides by 42. X equals, divided by 42, 14.75. Next, I've got some similar triangles, and I want to know what theorem or postulate tells us that they are similar, and there are 3 different options, and we're going to see all 3 here. So here, we've got a shared angle, so we've got a triangle here, and then an outer triangle here. They share that angle, so there's one angle. And then they've got this angle that's congruent, this right angle to this right angle. These are similar by the angle-angle similarity postulate. Next, I've got vertical angles here that are congruent. And then, just to be certain that these are proportional sides, I'll do the shorter side of this triangle over the shorter side of this triangle. So that's 6 over 12. And 6 goes into 6 one time and into 12 two times. So that simplifies to 1/2. And then the longer sides, 8 over 16. That's also 1/2. So the sides are proportional, and there's an angle between that's congruent. So that is side-angle-side similarity. And then my last set, if anything, it's going to be side-side-side similarity. Let's compare the smallest sides of each, so 10 and 15, 10 over 15. 5 goes into both of these 2 times and 3 times. Then let's compare the longest of each, 20 and 30. 10 goes into both of these 2 times and 3 times. Those are the same. Now, if the third one is the same, then they are proportional. They're all proportional, which means the triangles will be similar. 16 over 24. 8 goes into 16 2 times and into 24 3 times. So all 3 sets of sides simplify to the same ratio. So all the sides are proportional. That is side-side-side similarity. And our last portion for this video, we're going to find AB, the length of AB for each of these. Here's AB. I'll just put an X on that, so we'll solve for that X. AB here, I'll just put an X there. That'll simplify our proportions a little bit. So I'm just going to let the shapes here kind of determine my proportion. I've got 8 is to X as 6 is to 4. And I'll do cross multiplication, 6 times x, and 8 times 4. 8 times 4 is 32. And then I will divide by 6 and get x equals 32 divided by 6 is 5.3 repeating. 0.3 repeating is 1/3, so 5 and 1/3. Okay, again, I'll just let the shape kind of make my proportion for me. 2 is to x as 3 is to 9. So I've got 3 times x, and 9 times 2 is 18. And I'll divide by 3 and get x is 18 divided by 3 is 6. Okay, then I have x plus 8 is to x as 8 is to 6. Now I should actually adjust my answer a little bit here because I kind of made up that x when I put that there. We're really looking for the length of segment AB, so I'm going to change that to the length of segment AB is 5 1/3. And the length of segment AB is 6. Okay, now here I've got 8 times x and 6 times x plus 8. And I'm going to have to distribute. 8x equals 6x plus, let's see, 6 times 8 is 48. And let's subtract 6x from both sides of the equation and get 2x equals 48. And divide by 2, so we get x equals 24. Okay, now we're not looking for the value of x, we're looking for the length of AB, and the length of AB is this right here, which is x plus 8. So it's 24 plus 8, so AB is 24 plus 8 is 32, so the length of segment AB is 32. And then our last problem here, 15 is to x as 30 is to 20. So we'll do our cross products. 30x equals 15 times 20 is 300. And divide by 30, x is 300 divided by 30 is 10. So the length of AB is 10.